Alright, today we're doing points, lines, and planes. Another word for a postulate is called an axiom. Alright, this is another way that we can state it. But what a postulate is a statement that is accepted as true without proof. Okay, so it's a statement that is accepted as true without proof. Theorem, write tiny right here if you can, it's a little bit longer. It is a statement of conjecture that has been proven. It can be used as a reason to justify statements in other proofs. Like I said, I know that's a little long, but it's alright. I'm going to read both of these again. So a postulate is a statement that is accepted as true without proof. And a theorem is a statement of conjecture that has been proven, and it can be used as a reason to justify statements in other proofs. So we know theorems can be used to justify other statements in other proofs. So we can take a look at some examples, and we did these points, lines, and planes in our last unit. So if we have any two points, A and B, then what is existing through those 2 points? There is always exactly one line. Okay, so whenever there's 2 points, this is our reasoning, there's always going to be exactly one line. That's what we learned when we did points, lines, and planes. Alright, our next one. If we have a line, alright, so we already have a line, it's going to contain at least 2 points or more. So at least 2 points. Okay, so these are just other statements that we're making based on what we've known. Okay, I'm trying to go slow so I know everyone's copied down these notes. Okay, so if 2 lines intersect each other, then their intersection is going to create what? What did we create right here in the middle? Exactly 1 point. Okay, so we know that when 2 lines intersect, we are creating 1 point. If we have a plane, alright, we know a plane is going to at least contain 3 points, and specifically, these points are not in a line, so we are going to call them non-collinear points. Alright, so a plane contains at least 3 non-collinear points. Alright, let's go to the back side and continue on with the rest of these. So through any 3 points, sorry, it already has non-collinear right there. So through any 3 non-collinear points, there exists 1 plane. Alright? And just to go back and recap everything we've done, we talked about 2 points with a line, and then its inverse was a line that had 2 points. Alright? And then we also talked about an intersection of 2 lines having 1 point, and that's what we've done before. And we know that when we have a plane being named, we have exactly 3 points. So this is the inverse of what we just did on our last one. Alright, so now if we have 2 points that lie in a plane, Alright, so 2 points that lie in this plane. Then the line that goes through them is containing the lies in the plane. Then the line containing them lies in the plane. So this line right here is in the plane. Okay? And the last one to talk about for today is when we have two planes. So this is like two pieces of paper that are going in to each other. If they intersect, then their intersection where they meet is creating one line at their intersection. So in their intersection is a line that is being made. Alright, so if I were to sketch a diagram showing that TV intersecting PQ at point W, so we want to make that TW and WV are congruent to each other. So if I have a line T and V and I have a point, or sorry, another line segment P to Q is intersecting, I know that it is doing it at point W. We want to make this to show that TW, so this section right here, is congruent to WV, which is this section right here. Well, the best way that we can do that is we are going to put our tick marks. And now we have just sketched a diagram that shows line T to V intersecting P to Q at W has T to W equal or congruent to the length of W to V. So like we talked about before, if this was 5 in length, that means this is also 5 in length, and then their total from T to V is 10. Alright, the last thing we were going to talk about is we're just going to determine if these statements are true or false. So if we look at A, B, and F, are they collinear points? Yeah, A, B, and F are going down the same line, so this is true. They are collinear points. E, B, and D, there is no line that is going through them, so we can't justify and say that they are on the same line because we do not have the proof. A to B, this symbol right here means perpendicular, and what does perpendicular create? A 90-degree angle. Well, A to B right here is perpendicular to plane S. So this piece of paper that's cutting across right here, the line that goes up and down, is it creating a 90-degree angle right here? Yes, it is. We can see with our little box. So I'm going to say this is a true statement. A, F, and D are coplanar. Well, A is on plane T, F is also on plane T, but then D is over on plane S. So are these on the same plane? No, so we are going to say that is false. Alright, with those statements, now we can answer these questions. Where does plane S and plane T intersect? Well, if we remember, two planes that intersect, what does it create? A line. So I know that I need to name a line. So the line in between them has 2 points, B and C. So I can either name this B to C or C to B. And that is my line of my intersection. What points are non-coplanar to F? Well, I want to name any points that are not on the same plane as F. So let's identify what plane is F on. I notice it's here on T, so I know that F cannot be coplanar to B, C, or A, right? Because it's on the same plane, which means the only points that are not on that same plane are E and D. Alright, so points E and D are the only ones that are not on the piece of paper that is up and down. And then, lastly, where does A, F, and C to B intersect? Well, I know A to F is a line, C to B is also a line, and right there where they intersect each other, they meet at point B. And that is all for today. No homework.